get started with today's lesson. Today we're just going to do a lot of graphing. That's what the focus is. We're going to graph sine function, cosine function, then we're going to graph variations of sine and cosine functions. And after that, we're just going to graph tangent, cosecant, secant, all those functions. All right. So just a quick reminder that on Monday, we're going to have a quiz. The quiz is just going to cover material from yesterday and today. Covers 5.3, 5.4. Today is going to be 6.1 to 6.2. I post the homework rather late this afternoon. It is available if you want to take a quick look at the homework, and feel free to let me know if you have any questions, if the length is too long or if it's too difficult, let me know. Right. I think it should be manageable because all the graphing problems in the homework, actually, they give you all the choices, right? You just select the right choice. If you want, you can just, in your notebook, quickly sketch it and then choose the best choice that was given. I think in some sense, it makes it easier to graph, to find the correct graph for those problems. Anyway, so let's talk about graphing sine and cosine functions. All right. So I'm not going to do it from the beginning because at this point, I'm going to expect that you all know what the graph of sine and cosine look like. At least you learn how to graph it. Just in case you're curious, a quick reminder that if you want to graph sine and cosine, you can just pick nice angles. Let's say you want to graph f of x equals sine x. We're going to pick some x value that's a nice, for example, x could be 0 radians, pi over 6, pi over 4, and pi over 3, and pi over 2. So if we continue this table, we end up with a lot of corresponding y values. And we take all the y values, we plot it on this xy axis. And we know that for sine function, when the angle equals 0, sine of the angle 0 is equal to 0. Another way to think about it is if you have a unit circle, let's see, we're starting with the angle 0 here. Well, if we're starting with the angle 0, the y coordinate is going to be 0. It doesn't go anywhere above the x-axis. As the angle increases, for example, now is this angle, the y coordinate is going to increase. And then as the angle gets to pi over 2, the y coordinate is going to reach the maximum at 1. And then the y coordinate decreases if we follow along the circle. So the message is that at the angle equals 0, the y coordinate, the sine value of this angle equals 0. At pi over 2, it's going to reach the maximum value, which is 1. And when it gets to pi, it's going to come back down to 0. And when it goes to 3 pi over 2, if the angle continues to increase to 3 pi over 2, the y is going to be -1. So the sine is going to be -1. And when it gets to 2 pi, the sine value goes back to 0. So there you have this classic sine curve. So it goes up, become a slight curve there, and then curving downwards to pi, and then continue to decrease until it gets to 3 pi over 2, and then increase. So that's kind of one period, one full circle. And if we were to continue this, the graph will just continue in that direction. And the same thing on the left side, if we begin with 0 and move to a negative angle, so it goes to -1 first, go back to 0, +1, go back to 0. And it continues in both directions. So that's the function y equals sine x. I'm sure you all seen this before, but I want you to pay attention to a few things. One is a line through the middle of the function. So the started line, this is called the midline. And also the amplitude, which is from the highest point to the midline, or maybe from the lowest point to the midline. Usually we use the highest point to the midline. This distance is called the amplitude. So that's those two. And in addition to that, we also have to pay attention to the period. So because sine function sort of repeats the curve, the pattern repeats. So to find the period, what we sometimes do, we just pick the two highest points and to find the distance between them. So this is pi over 2 pi, 3 pi over 2, 2 pi. This is a 5 pi over 2. So the distance between pi over 2 and 5 pi over 2, that's 2 pi. So that's the period. You don't have to begin with the highest to highest. You can also begin with, for example, the origin, but the end of the period will be at 2 pi because that's where the full shape took place. So this is also a period. Right. So let me write down this value. So for the sine function, so y equals sine x. So we have this graph. The midline is at the x-axis, and we have this amplitude, which is 1 unit above. So the graph starting from the midline going up to the right and then repeats. Same thing on the left. So for this specific function, we have the period is equal to 2 pi. Make sure you remember this if you haven't. The midline is y equals 0. The amplitude is 1. So those are the three things that's more useful for this particular graph. And then I'm just going to give this to you. I'm not going to actually do the drawing. So if we have y equals negative sine x with the negative, so if you remember when we take sine function and then we multiply by -1 in front of it, the negative it does, it just flips the graph about the x-axis. So we end up with this graph. The midline is still the same, it doesn't change. The amplitude is still 1. The graph goes to the maximum at 1, the minimum at -1. But instead of like going up from the origin, from the midline, it actually goes downwards because it's being reflected. So it's going downwards starting from the origin. But the original graph from the origin is going upwards when it moved to the right. So that's something to keep in mind. So the period is still 2 pi. The midline is still y equals 0. The amplitude is still 1, doesn't change. But the starting direction is different if you start from the midline, the point on the midline, or the point on at the origin. All right. So similarly, we can graph cosine. Again, I'm not going to show the work. If you're interested, you can graph it by using the table. So y equals cosine x has a graph that's starting from, so the angle equals 0. Cosine of 0 radians is actually equal to 1. So starting with the highest point possible. The midline is still on the x-axis. So the graph starting here, by the time it reached pi over 2, it reached this x-axis of the midline, and then it just passed that midline and it continued to decrease. That's where it's reaching pi. So by the time it gets to pi, it reached the minimum. And then it goes back up to the x-axis at 3 pi over 2, and it continues to increase. So that's happening at 2 pi. So going from the maximum, go all the way to minimum, and then go back up to the maximum, that's a full period. For cosine x, period is still going to be 2 pi. The midline is still going to be y equals 0. The amplitude is still 1. So that's the same with sine x. but the difference is where it begins when x equals 0. It begins at the highest point and it's going downwards. And what about y equals negative cosine x? That's just going to be a reflection of cosine x. So if we take cosine x and we reflect it over the x-axis, well, the highest point is going to be corresponding to the lowest point. The point on the x-axis stays. The lowest point is going to be the highest point, and so on. So it goes from the lowest point, go up, past the midline, the x-axis, and to reach the maximum, and then it comes down, and then it reaches the lowest. So it's starting. So that's where the starting point is for negative cosine. I find it it's useful if you memorize where does the graph begin, instead of thinking about reflection, because if you draw a graph and you have to reflect it over x-axis, it's just a little bit too much work for cosine and sine. Now I want to point out that cosine and the negative cosine I drew here, they don't just end at 2 pi, or they don't just begin at the origin, the 0, x equals 0. They actually continues in both directions because it's periodic, so they never end. But for the convenience, we just draw the period from 0 to 2 pi. All right, so you all seen this before. Again, I'm not going to spend too much time on it. All right. So the next thing I want to talk about is sinusoidal functions. It's just sinusoidal functions. It's just a group of functions that looks like and it behaves like sine and a cosine. So functions like behave like sine or cosine, that they repeat. They're periodic and they have fixed amplitude, fixed midline, and the period. But the period may not be 2 pi. The amplitude may not be 1. So for example, the general formula, that 2, I'm going to write down both. So the general formula is f of x equals a sine, could be cosine, a sine bx minus c plus d. Right, and another version of this is going to be f of x equals a sine b parentheses. So inside the sine we have b as a factor, parentheses, x minus phi plus d. And if you think about, if we factor out a b from, so if we take this one given and then we factor out a b from this middle part, so if we factor this part, we get b times x minus c over b. So as you can see, the phi essentially is just c over b. That's what phi is. I want to be honest with you here. So I use the second form a lot because it's to my understanding, it's easier to graph if we have the formula in this form. So I would say if you are asked to graph some function given in the first form, just do the conversion. All you have to do is factor the b out of that parentheses part. All right, so I'm just going to use the second form here. So A is going to tell me the amplitude. So A is corresponding to amplitude, which is going to be absolute value of A. So if A is negative, the amplitude is going to be the absolute value of the negative number. If A is positive, it's just the number itself. And the B is going to tell me where the period, how long is the period. So the period P is equal to 2 pi over B, absolute value of B, because if B is negative, we're not going to take 2 pi divided by negative. So 2 pi over absolute value of B, so that's a period. And the phi is going to be horizontal shift. It's also called phase shift. And I should point out that the amplitude is kind of like a vertical stretch of sine y equals sine x, basically. Vertical stretch or compression. But in this graphing part, I'm only going to treat it like an amplitude. I'm not really going to get into the details of like, oh, do we vertically stretch it first? Or do we shift it? Or do we compress it horizontally? No, we just look at period and the phase shift. So that will consider both horizontal stretch and the horizontal shift. And the D is what the midline is. So y equals, so D is going to tell us midline is going to be y equals D. And if you think about transformation, D is really just shifting up or down. All right. So those are the 4 terms that we can get from the formula if we put the formula in the correct term. And they're very important because they're going to help us graphing any function, sine or cosine, doesn't matter. So here we have sine, but the sine could be just cosine. Everything looks the same. If we want to graph something in this form, it's very easy if you have all those 4 parts listed out. So for example, let's see, we have f of x equals 3 cosine x minus pi over 2 minus 5. Let's see, I want to put a coefficient in front of this x here, so I want to say 2 pi. So the function given is 3 times cosine, parentheses, 2 pi x minus pi over 2. And then outside we have minus pi. So this function is given in the first form. It's not the form that I use. So the first thing I'm going to do is I'm going to convert this to the correct form that I like. But before I do that, so let me write down what we need to find. So find the amplitude, period, phase shift, and vertical shift. Or sometimes called midline. Depends on whichever the problem says. So be careful, phase shift is not pi over 2 to the right. That's not the correct value. So if we want to find phase shift, we have to factor. Must factor. Well, you don't have to factor. You could also just take pi over 2 divided by 2 pi. That's also give you the phase shift. But in this case, I'm saying must factor, being a quote. All C over B if you want to use this formula. All right, so let's factor this. Really just this part we need to factor. So we get f of x equals 3 cosine, parentheses. We're going to take out 2 pi from the 2 pi x. So 2 pi, parentheses, x remaining from the first term, minus. Now, I want to know what I end up with if I take pi over 2 divided by 2 pi. So I want to know what's remaining after I pull out a 2 pi. So that's going to be pi over 2 times 1 over 2 pi. So that's going to be pi cancels, we got 1/4. So x minus 1/4 minus the 5 outside. So that's the factored form. And from here, we can say the amplitude is a number that we multiply cosine with in front. So amplitude A is just going to be 3. And the period is going to given by the number inside the parentheses, inside the cosine or sine function 2 pi. So the period is going to be P equals 2 pi. It's always going to be a 2 pi divided by whatever this number is, happen to be 2 pi in this case. So 2 pi divided by 2 pi, which is 1. So that's a period. And phase shift since I already have it factored, so the phase shift is just whatever this number tell me. Because it's negative, so that means we're going to move it 1/4 to the right. That's the phase shift. And then we have -5 at the end. That's just going to be the vertical shift. It's actually shifted down 5 units. It's also the midline. So -5 is the midline of vertical shift. So y equals -5, or you can say it's down 5 units. Any questions about this problem? Now, I want to point out that you're going to see a lot of this. So the period itself doesn't have to, the final answer don't have to have a pi. This again confirms that pi is not really a measurement. Pi is just a convenient value. So here the period is 1 radians. Okay. Any questions on this? All right, then. So now I have a couple graphs. So let's see, we're going to take graphs that we already know what the graphs look like. Now we're going to find the formula by going backwards to identify the formula. So let's see, copy this. All right, so here's this example. I have this function given. Let's suppose it's a, let's see, which function do we want it to be? Let's suppose it's a, so suppose it's a sine function, for example. And we want to know what's the formula that this function has. So find the formula for this function. Well, if we want to know the formula, I'm going to look for the general sinusoidal function. So I'm going to look for the function in the form of f of x equals a, because it says it's a sine, so a sine, parentheses. I'm going to put a b there, parentheses, x minus phi, plus a d. So I need to know the amplitude from the graph. I need to know the period from the graph so I can find b. And then I want to know the horizontal shift. And I want to know d, the midline. By just looking at the graph, it's a little bit easy to find the midline, right? Because we have the highs and the lowest and the highs. So the highest is at y equals 8, the lowest at y equals 0. So the line in the middle. So let me write down midline. So amplitude, period, phase shift, and then the midline. So we already know midline is at y equals 4. So that means d equals 4. And what else? Okay, if I know the midline, I can calculate the amplitude, right? Because that's just going to be the distance from highest to the midline, or from the lowest to the midline. So if this is my highest point at y equals 8, and the distance to this midline, that's going to be 4 units. So a equals 4. Could it be -4 or +4? I don't know, but it's 4 for now. So that's going to help us find a. Now, what about the period? The period is just going to be measured from the distance between 2 highest point or 2 lowest point, whichever you like. You just have to, look at and decide which one is the easiest to estimate the distance. It looks like if we use it doesn't matter, I guess. We can use the highest point on the left and the highest point on the right. So that's going to be the one on the left. It looks like it's corresponding to -7. The one on the right looks like it's corresponding to 3. So the distance, the period, is going to be 3 minus -7. So that's going to be 10. but period is 10, doesn't mean the b value is 10. Remember, period equals 2 pi over b. Period equals 2 pi over b. And then we can calculate the b from there because we know p is 10. So 10 equals 2 pi over b. And then move the switch the b and the 10. So b equals 2 pi over 10, which is pi over 5. So that's a b value, 5 over 5, pi over 5. Now, what about the horizontal shift, the phase shift? Well, that one we have to be a little bit more careful in order to find it. We have to know if this is a sine function, how much has it been shifted? Let's just suppose we take it as a positive sign, right? So we have a positive sine function. So recall that positive sine function starting at the midline, go up, and then coming down. So this is the midline. Okay, so I need to know this shape right here. So let me draw it with a different color. So I need to look for this shape. And the middle of that shape, that's where the starting point of the period is, if I want to use that point. But that's the part I want to match from the graph to the actual sine function. So that this yellow, this green shaded curve I have with this point right in the middle there, that's corresponding to this curve, isn't it? Or if you say, okay, what if we use the one on the left, this part? That's fine. It doesn't matter which one you use, just pick one. Both are correct. So I'm going to pick the one right in the middle of the graph. So if this is a positive sine x, and if I treat the function as a positive sine, I'm going to have to look at this part, see how much that has been shifted from the y-axis. So it looks like this point in the middle here on the y-axis is corresponding to 1. So it looks like we shifted to the right by 1 unit. Is it 1? Or is it more than 1? I'm debating because it doesn't look like 1. Because that actually should be, if everything is correct, this point actually should be, so let's see, we say the period is 10. So from here to there, that's 10. This is halfway, so that's halfway point. And this point on the midline, that's another halfway point of the second halfway. I don't think it's 1. Let me take it back. I think I didn't estimate correctly. So let's say this point, we want to know how much it has been shifted from the y-axis. Let's calculate this. So from -7 to 3, that's a full period, 10 units. Halfway there, corresponding to the minimum. So that's going to be -7 plus 5. So that should be -2. So let's just say this is -2. And then from -2 to 3, we need the halfway point because that's a point on the midline. So that's going to be, so that's 5 units divided by 2, 2.5. So that's actually -0.5. This is way off. And I apologize. So that actually should be at -0.5. It doesn't look right, but that's what it should be. It should be, this point on the midline should be exactly halfway between the lowest and the highest. So that should be 0.5. So the horizontal, so the phase shift is just going to be 0.5. To the right. I wish I have the grade line in the background. That would make it easier. But nevertheless, so So the trick here is if you want to find the phase shift, if you want to use the period, so the graph is always going to be, let's say starting, this is the maximum to maximum. So that's the graph from maximum to maximum, and it's periodic. So that's one period, and the minimum always corresponding to halfway point between the maximum. And the next point on the midline, again, that's going to be halfway point between the minimum and the maximum. And the point to the left side of the minimum, that's on the midline, that's also going to be halfway point between the maximum and the minimum. So it's always going to be starting at the maximum or midline, doesn't matter, after a sort of like a quarter of the period. So this is a 1/4 of the period, it moved to the next line. And then after another quarter of the period, it moved to a different line, the minimum here. And then after another quarter of the period, it moves back to the midline. And then another quarter of the period, it moves all the way up to the maximum weight again. So that's how I end up with phase shift equals 0.5. So now I have those values. I can put them into the function. So I can write down the actual function with those values now. That's going to be f of x is equal to a is full positive sine, so positive full sine. And the b, we found out that's pi over 5, parentheses, x minus phi, so x minus phi is 0.5. And then plus a d, which is full, the midline. So this is a function. Hopefully, if you were to work on an example like this, I don't think you're going to have any ambiguity with where the points should align. If I put this kind of problem on a quiz, I'll definitely make sure there's a graph that clearly indicate where the full points are within that period. Any questions about the approach? Kind of just to recap, if you want to know the formula from a graph, you have to know the amplitude, period, phase shift, and midline. Take those full values, put into the general formula, then you should be all set. All right, let's work on another example. Let's hope the second one is a little bit better. All right, here we go. I think it's better. So here's the second example. Again, we're going to find the formula for this function. The graph is given. So find a formula for this. It's not exactly sine, right? Because it's not centered at the origin, but we can still find a formula for this. So I'm going to use the general formula. Again, f of x equals a. Let's see, in this case, I'm going to practice both sine and cosine with you. So let's see, for the first one, a, we use sine. So a sine b, parentheses again, x minus phi plus d. And then the next part, I'm going to use cosine. But before I move on to that part, so I need to know the a, the period, the phase shift, the phase shift, and also d, the midline. All right, so first thing I do is I find the midline. So I know the minimum is at -1. Sorry, the maximum is at -1. The minimum is at -5. So the midline is the point, there's a line right through the middle of the minimum and maximum. So that's going to be at -3. So midline is y equals -3. So that's d value. And from the midline to the maximum or to the minimum, that's going to be the amplitude. So -1 to -3, that's 2 units. And in this case, again, I'm going to stick with sine. So let's find the period. Period is going to be from the distance between two maximum or two minimum. So the period is going to be from -3 to 1, or from -1 to 3. So let's say 1 minus -3, that's going to be 4. So that's 4. That's the period. And then we want to find a b. Remember that p equals 2 pi over b absolute value. We can just drop the absolute value in this case. So the p is 4, and then we can solve for b. b equals 2 pi over 4, which is pi over 2. That's this constant. And then the next part is need to find the phase shift. It's like if we look at a positive sine function, how much has it been shifted? So recall that positive sine function looks like this. And I'm only going to focus near the origin part, the point on the midline. So this is the midline. I'm looking at this part of the graph. So the rising part of the graph was the point on the midline. So that part is corresponding to this part, if you look at it. Of course, you could say, okay, what about using this part? That's fine. In that case, you just add a phase shift. But if we didn't use the one on the right, just use the part in the middle, that point should be on the y-axis, and it is on the y-axis. So that means we didn't have any phase shift. So no phase shift. If you were to, let's see, I'm going to erase this in a minute. Let's say use like, oh, the graph being shifted all the way up, all the way to the right here at x equals 4. And in that case, the phase shift equals 4. It depends on whichever of the graph you're going to match to the original sine, y equals sine x. And you can also use a negative sine function here if you want. For negative sine function, you will be looking for this part. You'll be looking for the decreasing part with the point on the midline. So that's either going to be here. So that's a phase shift of 2, or on the left with a phase shift of -2, because it's to the left side of x-axis. Y-axis. All right, so that's just different ways to write down the function. But here I'm sticking with positive sign. And now I can put in those values. So I get f of x equals a, which is 2, sine. b is pi over 2, parentheses, x minus phi, there's no phi, so just x minus 0. We don't even need the subtraction there. And the plus d, which is -3. Any questions on those? The next thing I want to do is take the same graph, but I want to practice finding the formula using cosine. It's the same graph, but we can use sine, cosine, positive cosine. Sorry, sine, cosine, negative sine, negative cosine. So the next part of what I want to do is I want to find a formula using cosine function. So that's just going to be f of x equals a cosine. Everything is the same in the general formula, b parentheses x minus phi plus d. So if we treat this as the cosine function, again, we need to know the midline. It turns out to be the same. The amplitude is still the same too. The period is the same, doesn't change. It's still going to be 4. That means the b is going to be pi over 2. I'm just going to copy from the part above. Now, phase shift is the one that you have to be careful. Let me use a different color. That's something we need to find out. And the midline doesn't change, which is still going to be at -3. So how do we find the phase shift if this is the cosine function instead of sine? Well, let's look at cosine function. We remember that cosine function starting at the highest point and it decreases to the lowest value, and on the left side is similar. So what I always look for is, I always look for the peak of the cosine function, but more importantly, the maximum where it's going to go down, because the maximum is on the y-axis. If the maximum is no longer on the y-axis, then I know it's being shifted. So that peak on the graph is this part right here at x equals 1. So it used to be on the y-axis for y equals cosine x. And now it's being shifted to the right. Now it's at 1. So that means the graph is being shifted to the right by 1 unit. So the phase shift is equal to 1. Because now this peak is at x equals 1. It's not at x equals 0 anymore. So that's a phase shift. And if I want to write down the correct formula at the very end, it's everything. So that's going to be f of x equals a is 2, cosine b is pi over 2, x minus phi is 1 unit to the right, plus d, which is -3. This is also a valid function for this graph, just like the one with the sign. So here you probably think, okay, how many functions can we write? In fact, there are infinitely many functions. It just depends on which part we want to consider being shifted from the original sine or cosine function. But if you just find the easiest one, then it's fine. All right, any questions on this particular example? I did not look for negative cosine function. I could. If we look for negative cosine function, then the only difference will be the phase shift. But remember, negative cosine starting from the lowest, go up and then go down. On the left, it's just the similar. So I always look for the minimum. I look at where that part is. This is y equals negative cosine x. This is y equals negative sine x. This is y equals positive sine x. So for each graph, I look for a specific part, see how that part is being moved away from the y-axis to the left or to the right, how many units. And that's going to tell me the phase shift. All right, any questions? All right, if you don't have questions, I'm actually going to graph those with you. So before I do that, I need to quickly charge my laptop. Just give me a minute. Okay. All right, now should be good. All right, so the next part is we're going to take some functions and we're actually going to graph it by hand with that calculator, do our best. So we're going to graph the following examples. The first one we're going to graph is f of x equals -2 sine 5x. I'm not going to use transformation because if we use transformation, it's just going to be a horizontal compression, a vertical stretch, and a reflection. It's just too many points and too messy to keep track of what's happening. So what I'm going to do is I'm going to use this new process. So from this, I'm going to identify the amplitude, period, phase shift. I'm just going to use phi, and the midline. So the amplitude is going to be absolute value of whatever the coefficient in front of sine. So that's the absolute value of -2 equals 2. Phase shift, I don't know, but I know the period, the b value. Sorry, phase shift, I do know in a minute. So I know the b value, which is going to be 5. And that 5 is going to help me find the period, which is going to be 2 pi divided by b, absolute value. So that's going to be 2 pi divided by 5. It's not a very nice number if you were to graph on the x-axis. The phase shift is how much we subtract from the x part. So this is the x. If we were to add a parentheses around it, we want to know how much is being subtracted from x directly. So that's a 0. And the midline is how we add to the sign part at the end. We're not adding anything, so it's 0 again. Midline is y equals 0. That's all we know. How are we going to use those values? B is not very useful when we graph, so we need the amplitude, the period, phase shift, midline to graph. So this is what I do. You probably learned it already in the past. To graph this, the first thing we do, we're just going to draw the x-axis. So this is the x-axis, that's a y. And I'm going to graph the midline first, which is y equals 0. So I'm going to use the dotted line for the y equals 0. And from there, so the first step, graph the midline. And from there, we're going to graph the amplitude. What I meant by that is we actually use the amplitude to graph where the maximum and minimum of the function will be. So amplitude is equal to 2. So we're going to go 2 units up, 2 units down. So let's say this is a 1 unit, 2 units, 1 unit, 2 units. So I'm going to draw a dotted line corresponding to the maximum when we go up 2 units. So that's at 2. And we're going to draw another dotted line when we go 2 units below the midline, -2. Those 3 dotted lines basically tell me where the graph is going to be at. It's going to be sandwiched between the top and bottom line. Okay, so that's midline, amplitude. And remember, there's no phase shift. So we're just going to begin a point on the y-axis and draw the correct graph. That's good. The period equals 2 pi over 5. So how do we graph 2 pi over 5, right? Now, the lazy way or the easiest way, I think, it doesn't matter. Say this is the origin. I'm just going to say, okay, that's 2 pi over 5. It doesn't matter. I'm going to pick a chunk. I'm going to call that 2 pi over 5. That's going to be 1 full period of the graph if we're starting at the origin to this point. All right, so what do we do next? Now, what do I do next is I'm going to, just like I did over here with the purple drawing, is I'm going to take the period, I'm going to divide it into 4 quarters. So basically add a halfway point. So I'm going to add a halfway point. So that's half of 2 pi over 5. So that's 2 pi over 5 times half. So that's 2 pi over 10, pi over 5. That's a halfway point. And then from there, I'm going to add another halfway point for the first 2 points from 0 to pi over 5. So it's halfway of that. So that's pi over 10. And I'm going to add another halfway point for the second half. So that's going to be, if we have pi over 10, 2 pi over 10, this must be 3 pi over 10. And then 2 pi over 5 is 4 pi over 10. So now I have 4 quarters. So that's step 3, graph the period. Means we labeled where the beginning and the end of the period is, and then we're going to put 3 points in the middle to get 4 quarters. And then the next step is actually to graph. So this function is negative sign. So this is a negative sign. So that means the graph is going to, if we have a negative sign, it's not going to go from the midline, the origin, go up. It's actually going to go down, go up, and like this. That's what negative sign is. So from this point on the midline, the origin there on the y-axis, what we do is we're going to decrease first. By the time we get to pi over 10, the first point, the first quarter ends, we should reach the minimum. And from there, we're going to go up to the midline. And from that point, we're going to continue to increase. And the next quarter is going to reach the maximum. And after it reaches the maximum, it's going to come down. to the midline. So that's a quarter. So that's how I graph it. First of all, I graph the period, and then I just divide it into four, put 3 points in the middle there, divide it evenly into 4 parts. And for each part, the graph is going to travel between 2 dotted lines. Here we begin with the midline, so it's going to go down to the lowest, and then in the next quarter, it's go up to the midline. So that's between 2 dotted lines, and then it's going to go up again to the maximum line, and then it's going to come back down to midline. So every quarter of the period is only going to travel between 2 dotted lines. So step 4, decide starting position and a graph. Excuse me. Any questions on this? And obviously, you know, to be honest, I don't think anyone is crazy asked you to graph like 3 periods or 4. If you want, you can graph another period. But basically just taking the same measurement and copy it to the right or to the left. So I'm going to say this is going to be, that's 4 pi over 5. This is, sorry, 4 pi over 10, 2 pi over 5. So this is going to be 5 pi over 10. 6 pi over 10 is going to be 3 pi over 5. And then 7 pi over 10. And 8 pi over 10, that's 4 pi over 5. So that's the end of the second period. And if we want to continue to graph, we're just going to take the graph, it continue to decrease there. By the time it reaches the end of the first quarter, it should reach the minimum. And then it's going to go up to the midline. And then it's going to continue to increase. By the time it reaches the next number, it's going to reach the maximum. And then it comes down. So it's kind of like a duplicating what we already have. Any questions? If you don't have any questions, I'm going to go through another example with graphing, which is a little bit different. So let's see, we're going to graph here. G of x is equal to negative cosine pi over 3x minus plus pi over 6. So it's not factored yet, it's just the way that it's given. So what I'm going to do before I do anything, I'm going to factor the cosine part. So that's going to be negative cosine. I'm going to take out pi over 3. So we get x plus pi over 6 divided by pi over 3. So that's going to be pi over 6 times 3 over pi. So that's going to be 1/2. So plus 1/2. Nothing else. So from this function, now we can write down, okay, the amplitude is going to be absolute value of -1, which is going to be 1. The b value, which is pi over 3, which allow us to find the period, is going to be 2 pi divided by pi over 3, the b value. So that's 2 pi times 3 over pi, so that's going to be 6. And the phase shift is going to be the value in the parentheses. So that's the positive half. So that means we're going to move it to the left half. So half to the left. Or you can just write -1/2. It's up to you. Or you can just write down half to the left. And there's no value added at the end. So the midline is y equals 0 again. With those values, so now we can actually start graphing. the midline is still going to be 0. So we have this dotted line on the x-axis. So this is the midline. And the amplitude is going to be 1. So we're going to go 1 unit up, 1 unit down. So I'm going to say this is my 1 unit. I'm going to draw a dotted line there. So that's the maximum value. It's going to touch that dotted line, and the minimum is going to touch this one. Okay, so now we have the period, which is 6, which is good. Let's just say we're starting here. Let's just say this is 6. Don't even have to give it too much thinking. So that's 6. And if you remember what I did last time is I take the period 6, I divide it into, or I find the halfway point, and then a quarter point, 3/4 point, right? We can do the same thing here, but remember we have a shift here. So I'm going to just lightly put the number here. So that's a 3. This is a 1.5. And the halfway between 3 and the 6, that's going to be 4.5. Before I start graphing the curve, I'm going to have to shift the curve to half units to the left. So I'm going to take all those 5 points, including the origin. I'm going to move everything half unit to the left. So each tick mark corresponding to 1.5 here. So if I only move half unit to the left, so half unit is probably, that's 1/3 of this. So that's going to be this much. So this is where the origin was on the y-axis. Now it's being shifted to the left to this green dot. And then the 1.5 is going to shift it about 0.5 to the left there. And the 3 is going to shift it by about 0.5 to the left. So that's going to be here. And the 4.5 is also going to shift it about 0.5 to the left. So that's going to be here. And the 6 is going to be at 5.5. So this is 5.5. This is a 4. This is 2.5. This is a 1. This is negative 0.5. So now I still have this 5 points. 1, 2, 3, 4, 5. 5 points, 4/4. So this 5 points divide the period into 4 parts. But the first one is going to be my starting point, not starting point on the actual function, but it's starting point of the period. And the 5.5 is the ending point of the period. Okay, so how do we graph? Well, this function is negative cosine. So recall y equals negative cosine x, begin with the minimum value on the y-axis and go up and coming down, go back to minimum. So that's negative cosine. So I must start with the minimum value on the y-axis. But here, remember, we have a shift. So the starting point is being shifted to the left. So the minimum value corresponding to negative 0.5 now. So that's where I begin. So I begin with this point. That's the minimum value corresponding to the new y-axis, the value being shifted from the y-axis. And by the time it hits the next green dot, it should reach the next line. So from here, it's going to go up and it's going to hit this green dot in that 1/4 of the period. And then it's continued to increase. By the time it reaches the maximum, it should be right above the next green dot. So it should be right there. And after it reaches the maximum, it's going to come in down. And when it reaches the midline again, it should be right at this is the following green dot, 4. And it's continued to decreasing. By the time it reaches the minimum, it's going to be directly below the next green dot. So when I graph them now, I only use a green dot, the new points after the shift. I did not use any of the old points I had, the 6, the 1.5, 3, or 4. Those points do not match with the graph. And obviously, if I want to continue to do this, I can just draw another period of this function on both ends, but there's no point to continue in that direction. Any questions on this? All right, let's do one more example before we take a break. I just want to point out one thing though. We probably get used to the idea of the periods must including pi or something. No, it doesn't. If we have just a number without pi, that's a period. It's actually pretty easy to graph because when you shift it, it's a lot easier to graph. Oh, we shift it to the left by 0.5, right? But if you have 6 pi or some pi in there, multiples of pi, it's difficult to shift 0.5 to the left. So I always think about, okay, if the period is just a real number without pi, it's actually a lot easier to graph. This is something that I experienced. All right, so let's look at another example. So we're going to graph this function. H of x equals -1/4 sine, parentheses pi over 2x plus pi minus 3. That doesn't matter, -3 or +3, it's all the same. Okay, so how do we graph this? Again, note that this is not factors, so we're going to factor this part. So I got -1/4 sine, parentheses pi over 2 times x plus. Now, what do we have left if we take pi over 2 out of pi? So that's pi divided by pi over 2. So that's going to be pi times 2 over pi. Pi over 1 times 2 over pi. Pi cancels, give me 2. So that's x plus 2 in the parentheses, minus 3. Oh, by the way, I don't know if you noticed that whenever I try to factor something not nice from a term, I just divide by it. So whatever the quotient is, so that's what's remaining. All right, from here, what we're going to do is we're going to just make a list of the full parts. So we have the amplitude, the b value, but I don't need it, but I need what I need the most is the period, phase shift, and any vertical shift or midline. So amplitude is going to be absolute value of the coefficient, -1/4. So that's going to be absolute value of -1/4, which is +1/4. And the b is going to be pi over 2, and which can allow us to find the period, which is going to be 2 pi divided by pi over 2. 2 pi divided by pi over 2 is on the side. 2 pi divided by pi over 2 is 2 pi times 2 over pi. Pi cancels, 2 times 2 is 4. And then the phase shift is 2 to the left. If we have addition, we move it to the left. The midline is going to be -3. After we identify those critical values, we can start graphing. It says the midline is -3, and then the amplitude is 1/4. So we get a pretty squeezed graph here. I'm going to be sort of cheating a little bit. I'm going to move the x-axis up. And I'm going to pick, let's see. This is going to be -1. That doesn't matter. There's no easy way. So that's the x-axis. This is -1, -2, -3, -4. So midline is at -3. So this is the midline. And the amplitude is going to be 1/4. So that's 1/4. This is the 1. So that's 1/2, 1/4. So it's going to be very difficult to draw, but I think we'll be fine. So this is the 1/4 above the midline, and then this is going to be 1/4 below. So the graph is going to be squeezed between those dotted lines. All right, so we took out the amplitude, the midline. Now let's look at the period and the phase shift. So the period is equal to 4. So I'm just going to say, I'm labeling all the points on the x-axis now. So let's see, this is the origin. So I'm going to say this is a 4. So that's a 2. This is a 1, 3. So if I divide the period into 4 quarters, those are the 3 points in the middle. But those are the points on the x-axis. The graph doesn't even touch the x-axis, right? And also that's a phase shift too. So let's apply the phase shift too. So every point will be shifted to the left by 2 units. So that's a -1, -2. So the origin is now here. And the 1 is now being shifted left to 2 units. It's going to be at -1. The 2 is going to be that origin. And the 4 is going to be at 2. Sorry, the 3 is at 2 is at origin, 3 is at 1, 4 is going to be at 2. So now I have this 5 new blue dots. So that marks the beginning and end of the period. Again, they are on the x-axis, but the graph should be centered about the midline between the maximum and minimum dotted line. So what do we do? So what I do next is I literally copy the 4 points directly to the midline. So the first point goes here to the midline. The second point is here. The third point is here. The fourth point is here. The fifth point is here. So it's kind of directly below. You don't have to draw those dotted lines, but if you want to have a visual, so that's the points. So those 5 points on the midline is the other points that I'm going to use to graph. And this is a negative sign. And remember that negative sign, starting at the midline, the origin, and it's going to go down, go up. So this point is right in the middle of the graph, but it's going downwards. So if I starting at this first point here, and I should go down, and by the time I reach the minimum, I should be directly below the second blue dot, end of the first quarter. So that's where it is. And then after that, it's going to go up, returning to the midline. And after that point, it's going to continue to increase. It's going to reach the maximum. I think I graphed it too much, but you kind of get that clue. So it's going to reach the maximum, and then it's going to come in down to the midline. So that's one period. Any questions about graphing this? At the end, you want to label the points correctly on the x-axis. So this is -2, -1, 0, 1, 2. We always label the values on the x-axis. We don't label them on the y-axis or on the midline. Well, let me take back. We don't label those points on the midline or somewhere else. We have to label them on the x-axis. The y-axis get their own labeling. Okay, any questions? All right, it's 7:19. Let's take a break. Let's see. Is 6 minutes going to be enough, or do we need a longer break? All right, why don't we take a 6-minute, oh, well, 5 minutes now. So let's take 5 minutes break, 7:25, 7:26-ish. And then we're just going to try to finish early if we can. So back by 7:25, 26. All right, welcome back. So let's continue with our lesson today. So the next thing we're going to talk about graphs of tangent x, secant x, and cosecant x. So first of all, let's talk about tangent. Again, I'm not going to graph it in details, but I just want to quickly sketch y equals, or f of x equals tangent x. And you'll probably seen it in the past, for tangent graph, there's a lot of vertical asymptotes. That's pi over 2. This is 0. This is negative pi over 2. And if we continue on the right side, so this is pi. This is 3 pi over 2. And then the graph is going to go like this, reaching the vertical asymptote. And I want to know that there's a very important point. Well, not important, it could be convenient reference point. So that's going to be at halfway between 0 and a pi over 2. So that's pi over 4, 1. And this is a negative pi over 4, negative 1. So those two are the like really nice points, obviously the origin. And for the next piece between pi over 2 and 3 pi over 2 is the same graph that repeats. Again, you can draw two really nice reference points. And for tangent of x, the period is not 2 pi, period is just pi. And they're going to have really nice point. If you were just to graph one period of tangent of x, the nice points are the origin, the pi over 4 comma 1, and the negative pi over 4 negative 1. But more generally, if we use the period here, so nice points going to be at the origin and also pi over p comma 1. Just double check, make sure it's correct. Oh, no, not pi over p, sorry. Period over 4 comma 1 and negative period over 4 comma negative 1. Those are the nice points. And then there's going to be vertical asymptotes. That's going to be at pi over 2, 3 pi over 2, negative pi over 2. So it's going to be at pi over 2 plus, hold on, let me just make sure it's correct. Pi over 2 plus pi over 2 times k, where k is an integer. So that's where the vertical asymptotes are. It's going to be pi over 2 plus multiples of pi. I don't know why I put 2 there. Multiples of pi. So pi over 2, 3 pi over 2, 5 pi over 2. So that's a vertical asymptote. Let's see, anything else? So the period is pi. Vertical asymptote is that pi over 2 plus pi times k. Nice point, it's going to be at 0, 0. Pi over 4, 1. Negative pi over 4, negative 1. Okay. So those are important things to remember when we graph tangent x. But most importantly, you need to remember that the vertical asymptotes. And the vertical asymptotes, I want to point out that they actually, if you forget to memorize this rule, you can always think about f of x equals tangent x, which is sine x over cosine x, right? So the vertical asymptotes happens when cosine x equals 0. So vertical asymptote happens when cosine x equals 0. And if you go back to the cosine function, Oh, well, let me just quickly sketch it. Cosine function starting at the highest, and when it reached 0, this is at pi over 2, decrease pi, and 3 pi over 2, and then continue to increase. So at pi over 2, 3 pi over 2, so cosine is always going to be 0, but when we divide by 0, we get undefined. So that's why we have vertical asymptote. So that's tangent function. And a general case with tangent would be, let's see, f of x equals a tangent of bx. And the a here is just going to be a vertical stretch of vertical compression. You can think about, it's not quite the amplitude. So this is the vertical stretch or compression, and a b is a constant that's going to affect the period because it's a horizontal stretch or compression, but we can write down the period is equal to pi divided by absolute value of b. So that's a period of this specific tangent function in the form. And the nice points are still going to be the origin, p over 4 comma 1, and negative p over 4 comma negative 1. So if you want to memorize those points, you can do that. The vertical asymptote is going to be a little bit different in the general formula. So vertical asymptote is going to be at the period over 2 plus period times k. So if the period is pi, so it's going to be at pi over 2 plus pi times k. If the period is pi over 2, then it's going to be at pi over 4 plus pi over 2 times k, where k is an integer. But again, you don't have to memorize, worst case, just try to graph it. For example, if I want to graph this function, so example, graph f of x equals 2 tangent pi over 6x. So the b value is pi over 6. I can find out the period. The a, the vertical stretch, is going to be 2. I made a mistake earlier. I'll fix it in a minute. Yep, I did make a mistake. Well, let me fix it now. So if we have an a here, the nice point is not at p over 4, 1 is actually p over 4a. And then negative p over 4, negative a, because the 1 was stretched by a factor of a. That's what happens. So the b here is pi over 6. The a is 2. So the period is going to be pi divided by absolute value of b. So that's pi over 6. So that's going to be pi times 6 over pi. That's going to be 6. So that's the period. And then the nice points going to be at 0, 0, 6 over 4, comma a, which is 2. And then negative 6 over 4, comma negative a, negative 2. So 6 over 4 is 3/2. So 3/2, comma 2, negative 3/2, comma negative 2. And the vertical asymptotes is going to be at period over 2. So that's going to be 3 plus 6 times k. So it's going to be at 3, 9, 15. etc. So if we were to graph this quickly, so that's going to be, there's a vertical asymptote S3. The next one is going to get 3 plus 6, 9, so 6, 9. The one on the left is going to be 3 plus -6, so that's -3. So those are the vertical asymptotes. And the nice points we have here, that's at the origin, and also 3/2. So 6/4 is 3/2, comma 2, and -3/2, comma -2. So we're just going to draw a nice curve approaching the vertical asymptotes. And the same thing for the next period, we can do the same thing. And to be honest, most of the time, even if you don't graph the nice points, if you get the vertical asymptote correct, and generally we consider that's a correct graph. All right, any questions on this? Okay, so the question is, what if we have the general formula of tangent with shifts, like a vertical shift and the horizontal shift? Let's see, f of x equals a tangent bx minus c plus d. So if we have something like this, kind of like the sine and cosine, what do we do? Well, the first thing we do is the same thing like we did before. We're going to factor the parentheses part to get the phase shift. So that's going to be a tangent parentheses b parentheses x minus c over b. But if you remember that c over b itself, it's just the phase shift. So we could just rewrite this c over b as phi if we want. So that's the first thing. So that's going to tell us how much we shift the graph to the left. And the d is going to tell us where we move it up, because with the regular tangent, the midline is right on the x-axis. With the d there, it's going to tell us how much we move it up and down. So the general strategy is to graph this function, to graph this function, f of x. What we do is we graph y equals a tangent b first, bx, and then shift the graph to the right by phi and shift up by d. So let's try to graph one function. So here's the example I have, which is y equals -2 tangent pi x plus pi plus 1. The first thing I'm going to rewrite by factoring, so that's -2 tangent pi times x plus 1 plus a 1 outside. And from here, I know that the b equals pi. So that means the period is going to be pi divided by pi, which is 1. And the phase shift, it's going to be 1 unit to the left because it's plus 1 there. And then we're going to have 2 tangents. That's fine. And also we have a negative. That means we have flip over the. So this is going to tell us that we're going to flip over x-axis. And the 1 is going to be up 1. So a lot of pieces going on here. So let's try to graph them. So first thing I'm going to do is I'm going to use the period, which is 1. That means we're going to graph y equals 2 tangent of pi x first, using the period that's 1. So at p over 2, 1/2 here, we're going to have a vertical asymptote. So vertical asymptote is going to be at p over 2 plus p times k. So that's going to be at 1/2 plus k value. So 1/2, 1/2 plus 1, 3/2. And also on the left side, it's going to be at -1/2. I'm not going to bother with the nice points. So I'm going to just say that from the origin, this 2 tangent pi x is going to go up and go down on the left. So that's the 2 tangent pi x. From there, if I want to achieve the function that's given, I have to flip this function over the x-axis first. So I'm going to take this flip over the x-axis. So I get this one. So this is a -2 tangent pi x. And then I have to move it up 1 unit, shift it to the left 1 unit. So if I take this graph, move it up 1 unit, so this origin is going to be at this point. And the vertical asymptote stays. So I get this graph. So this is a -2 tangent pi x plus 1, shift it up 1. And the very last thing we have to do is move it to the left by 1. So the 1/2 and the -1/2, everything shifted to the left by 1. So we basically end up, so there's a -1, -3/2. So we basically end up in this period on the left. That point shifted to the left by 1, so that's end up here. And we get this final graph. That's a -2 tangent pi x plus 1, and then plus 1. So that's the original function that we need to graph. Any questions about this graphing? All right. If you don't have questions on this, let's take a look at one example I have earlier on the side here. Where was it? So here's a graph. Where was it? Okay, so here's a graph of tangent. And we're going to find a function for this graph. So find a function, a formula for this function. So here we already have this graph, and what we need to do here is to use the graph to, well, let's just say the general formula is going to be f of x equals a tangent parentheses b parentheses x minus phi plus the midline, which is how much we shift it up and down from the x-axis. Let's see, the first thing with tangent is easier to identify the period, which is going to be from -4 to +4, so period equals 8. So that means period equals 8. The b is going to be, well, we know that 8 equals 2 pi over b. So b equals, sorry, pi over b, so b equals pi over 8. It's not 2 pi with tangent. The period is just pi, so that's pi over 8. That's the b value. And is this tangent going to be shifted left or right from the x-axis? Looks like the point on the middle of the graph is right at the origin, so there's no phase shift. So phase shift equals 0. So is it being shifted up or down from the x-axis? No, it's still at the origin. So D, the midline, is also equal to 0. Now, what about A, right? How do we know if it's being stretched or not stretched? Well, a trick is that we can look at halfway point between the origin, the point in the middle of that graph of that piece, and the asymptote. So that's at x equals 2, and then we look, see where the y is. Y is also at 2. So that 2 of y value is going to tell you what the A is, 2. And worst case, let's say you don't know, so let's just leave it. So f of x equals A, let's see if we don't know what A is. A tangent B is pi over 8, x minus 0 plus 0. So let's just say we don't know what A is. How do we find it? Well, we can always plug in the point 2, 2. So plug in point 2, 2 to find A. So that's going to be 2 equals A tangent pi over 8 times 2. So that's A tangent pi over 4. And if you remember, pi over 4 is just 1. So you just get A equals 2. So 2 ways to find the constant A, the vertical stretch. Either plug in a point at the end or just look at the graph. So at the end, f of x equals 2 tangent pi over 8 x. There's no phase shift, no vertical shift. All right, any questions on those? Okay, I'm going to go, it's almost 8, so I'm going to take a little bit more time here. Let's do two functions we have to graph. Let me try to go through them as much as possible before it's too late. So graph of of f of x equals secant x, and also later on we're going to graph cosecant x. Now, in order to graph f of x equals secant x, the easiest way is to graph cosine function first, because recall that secant x is 1 over cosine x. So we're just going to take the reciprocal of the cosine x. So let me graph cosine x first. So graph y equals cosine x first. So that's going to be starting at the maximum, going down, lowest, and go back to midline, go to the maximum, and coming down again, and continue. Okay, how do we graph the reciprocal? So this is y equals cosine x. Secant is the reciprocal of this. So basically, we take all the y values, we put into the denominator and try to calculate the quotient and plot it. Well, if you remember that we have a few nice y values, so that's y equals 1. This is y equals 0. This is y equals -1. This is 0. So we could pick those really nice y values and try to divide that from 1, see what we have. If I take this point on the y-axis, 1, I divide it from 1, I get 1 divided by 1 is still 1, so that point doesn't go anywhere. But if I take this point, y equals 0, and I divide it from 1, so I know that 1 divided by 0 is undefined, so this 0 actually corresponds to a vertical asymptote. So every time I have a point on the x-axis for y equals cosine x, I'm going to have a vertical asymptote for y equals secant x, because I cannot divide by 0. And every time I'm going to have y equals 1, the graph of secant is going to have exactly the same point. It doesn't go anywhere, because 1 divided by 1 is 1. And every time I'm going to have y equals -1, the secant also going to have that point, because 1 divided by -1 is still -1. So those maximum minimum points on the cosine stays where they are on the secant, but all the zeros become vertical asymptotes, because we cannot divide by 0 in the denominator. So cosine x cannot equal 0. So vertical asymptotes happens when cosine x equals 0. Now, what about the rest of the graph? Well, let's think about it. If let's see, starting from this y-axis point on the y-axis, go right. If I divide by a number that's slightly less than 1, it's going to be more than 1. If I divide by a number that really small, it's actually end up to be a number really big. So we kind of have this graph. Let me use a different color. So this is a graph of secant. It's kind of like a parabola, but not exactly parabola function, but it has a shape. So between every two dotted lines, if you have a cosine x graph there, it's just going to be a sort of parabola there, and on the same side. So that's a secant graph. It's just a reciprocal of cosine x. And I just want to note a couple of things with this specific function. For the f of x equals secant x, we have the period is still going to be 2 pi, just like the cosine function. It's not pi, it's 2 pi. And then the domain, or the vertical asymptote. So the vertical asymptote happens at, so if you remember, this is pi over 2, this is 3 pi over 2, this is a 5 pi over 2. So the vertical asymptote happens at the period. Let me make sure it's correct. Yep. Yep, period over 4 times k, where k is equal to odd integers. So in this particular example, if we take the period 2 pi divided by 4, we get pi over 2. And it's going to be odd multiples of pi over 2. Pi over 2 times 3 pi times 1, pi over 2 times 3 times 5, and so on. So the vertical asymptote happens at the period over 4 plus times k. And the range of cosine function for this particular example, it happens at it's either going to be below -1 or above 1. So that's going to be from -infinity to -1, and from 1 to positive infinity. So that's the range. It's not average. In the middle, that's a big part that's missing, where cosine was. So that's a secant. Let me quickly graph cosecant. It's just really the same way to graph cosecant. We graph sine first. To graph f of x equals cosecant x, what we do is we graph y equals sine x first, because cosecant x is equal to 1 over sine x. So we're going to graph sine x and then find the reciprocal. So for the sine function, every time we have a 0 on the x-axis, so y equals sine x, there must be a vertical asymptote for the cosecant function, because we have 1 divided by 0 undefined, so the y value at those particular x values are undefined for the cosecant x. And every time we have a 1 or -1, those points stays. And again, for each part, we're just going to draw the parabola. So the graph for cosecant, but just make sure that whatever the parabola you draw, the U shape, is going to fit between the two vertical asymptotes. So the green one I draw is y equals cosecant x. We're just going to keep the sign there. Again, you can erase it if you want at the end, but there's no need to go through the trouble, because the sine x is going to tell us how we end up with the function cosecant x. So to note that f of x equals cosecant x, the period, just like sine, the period is 2 pi. And the vertical asymptotes, instead of happening at the period divided by 4 times odd integers, it's going to happen at periods divided by 4 times even integers, because the vertical asymptotes happens at 0. This is a pi. This is 2 pi. This is 3 pi. So period divided by 4 is pi over 2 times even. I'm going to use n, where n is even integer. And then the range is just like the secant of x. It's going to be from -infinity to -1, and also from 1 to infinity. Any questions on this? All right, I have one more example. I'm going to go through this and then I'm going to stop there. I don't think there's any point continuing. All right, so last example here. So suppose we have example, we want to graph f of x equals -6 cosecant 4x plus 2 minus 1. Okay, how do we graph this? Right? Well, to graph this, what we do is we actually going to convert it to a sine first. So what we're going to do is we're going to graph, let's see, y equals -6 sine 4x plus 2 minus 1. And then we're just going to do what we did just now find the reciprocal of that function. All right, let's see. Oh, wait a minute. Wait. I'm going to screw up on this. I'm going to make a mistake on this. That's not good. You know what? I'm not going to do this way. This is going to give us a big problem. Because they're not equivalent. So I was jumping ahead of me here because this is not so the one given is not the reciprocal of this one. So the reciprocal is, so what we're going to do is we're going to take this part. So y equals cosecant 4x plus 2 is the reciprocal of sine. So that's equal to of sine 4x plus 2. Only this part, the -6 and the -1, they're not really part of the reciprocal because we know that cosecant 4x plus 2 is equal to 1 over sine 4x plus 2. So what we're going to do is we're going to graph y equals sine 4x plus 2 first. So let's graph that. So that's going to be sine 4 times x plus 1/2. So this function is going to have amplitude, that's a 1. B is 4. So period equals period is equal to 2 pi divided by 4. So that's a pi over 2. And the phase shift is going to be half to the left. That's not going to be nice. But the midline is going to be 0. Well, nevertheless, let's just do our best here. So the amplitude, so the midline is at 0. The amplitude is at 1. So let's call this 1. This is -1. So we have those two dotted lines. And the period is at pi over 2. So 0, let's see, this is pi over 2. We get 4 points in the middle, sorry, 3 points in the middle, 4 quarters. And then we're going to shift it left by half. So that's going to be, if we shift it left by half, so pi over 2, this is a pi over 4. That's actually a little bit less than 1. So this is about half. So if we, so that's less than 1, this is less than half. Sorry, the number's not really working well in this example. Let me see, did I make any mistake here? All right, I'm just going to shift every point to the left by half. So that's a little bit less than half. So if I shift it to the left by half, it's going to be somewhere there. This point, so nope. So the first point is going to be somewhere here. And at this point, shift it left by half, it's probably then ends up there. This point is going to be a little bit to the left here. And this point is going to be here. That point is going to be here. So those are the 5 points I have. And from here, I'm going to draw the graph sine. So that's going to, starting at the midline, it's going to go up and coming down to the midline, go to the lowest and go up. So that's 1 full period. And so that's a sine, but the original function has cosecant. So the next thing we're going to graph cosecant. So step 2, graph cosecant for 4x plus 2, which is the reciprocal of sine. So from there, we're just going to draw vertical asymptotes for all the points that we have 0, and the maximum at 1 and the minimum at -1, so they stay. So we get this reciprocal graph. So that's a cosecant 4x plus 2. And the remaining part, so that's, we have to figure out the -6 and the -1. So the -6 tell us that we're going to reflect over the x-axis and also vertically stretch by 6. So I'm going to use a blue color here. So if I want to reflect over the x-axis, so this graph becomes here. And this graph on the left becomes this region. So the 2 blue one. So this blue one is negative cosecant 4x plus 2. And then we're going to stretch it vertically by 6. It's just going to be a little bit skinnier. I'm going to be careful here. So that's a 1. If we stretch by 6, it's going to be here. And this point is probably way up here. 6. And then this -1 is going to be at -6. And the graph is going to go down like this. Not pretty. And the last thing we do is shift it down 1. So if we move it down 1 unit, the 6 becomes 5. So we get this graph, still have this vertical asymptote here. And this graph is going to shift it down to -7. Still has a vertical asymptote. All right, anyway, so that was the last example. It's a little bit more trouble than I expected. Don't worry, you're not going to graph this by hand on a quiz, but I just want to show you as an example what you should be doing if you see example like this. It's really using the idea of like, okay, cosecant is the reciprocal of sine. So which part of sine which part do we graph first? We graph the sine for the corresponding part, find the reciprocal, and then perform the shift and the stretch. Just vertically. Horizontally, it's already being taken care of when we graph the sine. Okay, so that was quite an example. Any questions on this? Or, well, I guess say don't worry about the last example I did. Well, at least just kind of pay attention to know what's going on. And the cosecant x you have to know, the secant x you have to know. Those two, like how to quickly sketch them. And how to find the vertical asymptote. Even if you forget about the formula to find the vertical asymptote, if you can kind of graph them quickly using cosine and sine, then you can find the vertical asymptote. And the tangent you have to know. And the same thing with sine and the cosine, mostly sine and the cosine functions. All right, anyway. Any questions on those examples? You're probably going to see one example. I don't think it's going to be as complicated as the last example I did, but maybe similar. to some degree. Just do your best on that. I think it's good to try something that you probably don't have a lot of experience with. All right. If you don't have any questions, let's see. It's almost 8:30. So, and on that note, I'm just going to let you go, and I'll see you on Monday. Don't, like I said, on the quiz, you're not going to see something like this last example or on the exam. All right. Take care, everyone. Bye-bye. I'll see you Monday.
Thanks.
Thanks.
All right. Take care, Johnson. Bye-bye. See you, Brian.